Okay, to make these notes a little bit easier, I did ask you guys to either print this document before or copy the document before, because hopefully you guys have that done. Okay, so let's go over acceleration. So acceleration, it's in the most simplest definition, it's going to be a change in velocity. Okay, so it is a change in velocity. So if we remember, velocity is composed of speed plus a certain direction. Okay, so that means anytime we change the speed, for example, if I speed up, that's acceleration. If I slow down, that's acceleration. Or if I change direction, that's also acceleration. For example, let's say I had this pen here and it's moving at a constant speed. If it's at a constant speed, meaning the speed doesn't change, then it's not accelerating. But if I throw this pencil across, it's going to change speed. It's going to speed up, right? So it would be accelerating. If something can also be moving at a constant speed, but it can change direction, and therefore if it changes direction, it changes velocity, so it is accelerating. Okay? So let's break down the equation and go from there. So if we remember, this is just a rate and change. Okay, so it's a rate. So acceleration is the rate of change of velocity. Okay, so for speed, it was my distance over time. But now distance isn't changing, speed is changing. So our equation is acceleration equals not distance, but the change in velocity, which is my final velocity, take away my initial velocity, divided by my time. Okay, so this, those are new variables, right? We haven't seen that, but we have seen time. So let's go ahead and break it down and go over what these mean. So I know, well, I don't know, but we're going to figure out that A, if we guessed it, it would be, well, A stands for acceleration. Okay? All right. Then I have T. That stands for time. It's pretty straightforward. Then I have velocity, F. What does that stand for? That just stands for velocity final. Okay, what was my final speed? Then we have VI, which is my velocity initial, or my initial velocity. So what's initial? It's just what was our starting velocity. Okay? All right. Now let's go over what are our units for this. Well, we know velocity is speed, and we measure that in meters per second, right? We've been doing that. And this is also speed. It's just the first speed, meters per second. Time, we know we measure that by seconds. Okay? In acceleration, we are dividing speed by time. In other words, we are going meters per second divided by second. Okay? So when we have something like that, we actually bring this to the bottom. You don't have to know why. You just have to remember that acceleration has the units of meters. If I bring this to the bottom, I have two S's. So it would be meters per second squared. Okay, so those are my units for acceleration. Those are units that we have not seen before, so that's different, right? All right. So this goes over a couple of strategies to solve the problem. So first, we list every single one of these. That's step one. Step two, you plug in whatever you have into the equation. And step three, you solve for whatever's missing. Okay? So there's a couple of things you need to know, though, that are going to help you out. So things that we want to watch out for. So first, if we see something that says at rest, okay, that actually is giving us some information. It's giving us a hint. If something's at rest, then that means it's at rest. The starting speed is zero. It's not moving, right? So that means if you see at rest, that means my initial velocity is 0 meters per second. Okay? Also, you might see something that says to a stop. So if something comes to a stop, Well, if you come to a stop, then that means you have a certain speed, but then you stop. So your final speed is 0 meters per second. Okay? So those are two kind of key phrases that we want to look for: at rest or to a stop. Okay? And last of all, keep in mind there might be times when you get a negative, or let me actually put this here, negative acceleration. Okay? Just abbreviate. What does that mean? That just means if a positive means we're speeding up, a negative for acceleration means we are slowing down. Okay? So just keep in mind that it is possible to get a negative number. All right. Really, the best way to work through these problems is to just kind of work through some and get familiar with them and go through the process of listing everything. Okay? So that's why I asked you guys to kind of copy down these sets before. All right. So let's work through this problem. So if we go back to our steps, again, we list, we plug, then we solve. Okay? So first, let's list. So it says a car accelerates uniformly from 10 meters per second to 40 meters per second in 3 seconds. What is the acceleration? Okay, so I don't know acceleration, so I'm going to put a question mark. I'm going to list everything. V initial, V final, and last of all, time. Okay, so every problem is going to give you 3 things, and you have to solve for 1. Maybe you don't think it's giving you 3 things, but every problem, I can guarantee you, gives you 3 things, and you have to be able to solve for 1 thing. Okay? So in this example here, it says I started at 10, so that's my initial speed, 10 meters per second. Right? My final speed was 40, so that's 40 meters per second. Okay? Then how long did it take to do that? 3. All right. I know acceleration equals V final take away V initial divided by time, right? Okay, so if my V final is 40, right? It's 40. I'm going to go ahead and plug that in. So I'm going to leave the numbers out for now because it gets a little, the units, because it gets a little sloppy. So it's 40. Take away 10 divided by 3. Okay, that's going to give me 40. Take away 10 is 30 divided by 3. Well, 30 divided by 3 is just 10. Okay, so my speed is 10. Well, what are my units? Well, it was acceleration. Acceleration is meters per second squared, right? Meters per second squared. Okay, and that's how we do it. We just plug in our information, we solve, and we go from there. Okay, let's go through the problems. Let's work a little bit quicker on this one. So, a lizard accelerates from rest to 10 meters per second in 0 seconds. What is the lizard's acceleration? Well, from rest, that's my key word right there. That means it started at 0. So, do I know velocity? No, I put a question mark. Do I know my final velocity? Well, actually, let's start with the initial here. Final and then time. Do I know my initial velocity? Yeah, initially we started at rest, so it was 0. What was my final velocity? Well, I went up to 10, so it is 10 meters per second. That's per second. Then last of all, my time was 4. Okay? So then I just plug it in. Okay, so I go ahead and I plug it in. I already know this equation, right? So I'm just going to go and plug it in right away. 10 is my final. Take away my initial, which was 0, divided by 4. Okay? 10 take away 0 equals 10. So 10 divided by 4. I can go ahead and put that in my calculator. So you don't have to do the math in your head, or you guys also don't have to do the math. You can use a calculator for any of these problems. Okay, so I just go 10 divided by 4 gives me 2.5. Okay, 2.5. Again, acceleration meters per second squared. Okay. All right. Last of all, let's go back here. So let's work again. Let's continue working through these problems. So this problem says a car while traveling along a highway, a driver slows from 24 meters per second to a stop. Well, now I'm going to show you how we can eventually start skipping these steps, but at the beginning I want you to do it, okay? So if he's driving from this speed and he comes to a stop, then that means my final speed must have been 0, and my initial speed was 24, right? And well, that's just my time. So what is the acceleration? Well, I already have everything I need here. So acceleration equals final, which is 0, take away 24, divided by 12. 0 take away 24, that's not 24 because we're taking it away, so it's negative. Negative 24 divided by 12. 24 divided by 12 gives me 2, negative 2 meters per second squared. Now let's think, does that make sense? Well, if I came to a stop, I slow down. And if I slow down, then it should be negative, right? Because negative acceleration means slowing down. So yes, you can get a negative number here, and this would be correct. Okay. In this one, I skipped these steps because once you get a little bit better at it, you can skip the steps. But for now, I want you to kind of just continue to go through them. Okay. All right. You're also going to encounter some problems that are a little bit more difficult. Okay. I'm going to show you guys how to do these, kind of doing the same process that we've been doing here. All right. So let's go ahead and look at this problem. It says, if a Ferrari with an initial velocity of 10 meters per second accelerates at 50 meters per second, that's just the same thing as meters per second squared. I don't want you guys to get confused there. For 3 seconds. What is the final velocity? So this is a different problem, and you will see some of these. These are just the more of the challenge problems. Okay, so acceleration, initial, final, time, same process. This problem is different because I'm given my acceleration. My acceleration is 50. Okay, I'm just going to put the numbers for now. My velocity initially, well, it tells me initial velocity of 10. However, I don't know this. That's what I'm looking for. Remember, the problems always give us 3 things and we find 1. Now we're looking for time. Well, it did all this acceleration in 3 seconds, right? All right, so let's go through the process. Let's plug it in. So I know acceleration equals v final, take away v initial, divided by time. All righty. Let's take all these numbers and plug them in. So rather than putting A, I'm going to put 50 because I'm going to plug it in, right? So I go 50 equals, I don't know V final, so I can't put anything. I can just put VF to represent the unknown. Take away 10, because that's my initial, right? Divided by my time, which was 3. Okay, so we've just gone through step 1, list variables. Step 2, plug into the equation. Now we got to go step 3, solve for the missing variable. That's the most difficult part. We have to solve for this missing variable, that unknown. Okay, and what does that mean? Solve for it? That just means get it by itself on one side. That's all it means. Okay, let's go ahead and I'm gonna go over how to do this with you guys. This is it could be difficult, but when you have something like this, first of all, you want to realize that you have a fraction. You don't want to deal with fractions. Fractions are sloppy and they're just difficult to work with. So we can move this over to the other side by cross multiplying. So what I'm going to do is I'm just going to put this over 1, right? Because it's the same thing. If I cross multiply, I'm going to multiply this. Gives me 3 times 50 gives me 150, right? So I'm multiplying across here. and then I multiply this. Well, 1 times this just gives me the same thing, so this equal sign doesn't go away, right? It's VF, take away 10 goes to the other side. All right? Now, this is super simple algebra. Just think about this like an x. Well, how would we get this to the other side? Well, the opposite of negative 10 is going to be positive 10. If you do it to one side, you got to do it to the other side. Cancel. My answer is 160 equals V final. And that's my answer. What are my units? Well, it was velocity. So velocity is always, we've been measuring it in meters per second. Meters per second. Okay? That's the one that's pretty difficult. Okay, let's go through the last problem, which you will see a few times as well. Okay? So, but we go through the same process. Alright, so for this one it says a car accelerates at a rate of 4 meters per second if the original speed is 8. Original means initial. So that's my initial. How many seconds does it take to reach its final speed of 25? Okay, so acceleration equals 4. V initial equals 8. V final equals 25. And time is what we're looking for. Okay, same thing. I list them, I plug in, and we go from there. So I already have the equation here. I'm not going to rewrite it. So rather than A, I put 4. 4 equals final velocity. Final is 25. Right? Take away. I already have my initial. Initial is 8. Right? Divided by T, because I don't know T. I don't know time. All right, let's simplify this. How do we simplify this? Well, I know 25 take away 8. I can do that, right? So 25 take away 8 would give me 17. Okay, so I can rewrite this as 4 equals 17 divided by T. All I did was I just took these two away, right? All right. Now, how do we solve this? You can cross multiply. That's one way. Or you can just multiply both sides by T. We've been cross multiplying, so let's do that, right? Okay, so I'm going to put this by 1. Now we cross multiply. Well, 4 times T gives me 4T, right? And 17 times 1, well, that just gives me 17. All right, now we're almost there. How do I get T by itself? Well, right now I'm multiplying 4, so I need to get that on the other side. Well, what's the opposite of multiply by 4? Divided by 4. Divided by 4, 17 divided by 4. You put that in your calculator. So I'm going to put 17 divided by 4. Gives me 4.2. So my answer is 4.25. What are my units? Well, I was looking for time, so it is seconds. Okay, so these are the most difficult ones. This and this, you'll encounter a few of those, but I wanted to show you guys so you're not surprised when they come up. Okay, but if you can do these, then you can do any problem.